All right, today we're continuing to look at quadratic equations. We're going to look at standard form today. So standard form is y equals, or f of x equals, ax squared plus bx plus c. So whenever you see a quadratic in this form, this is where it starts with your x squared term, and then it has an x term and a c term, a constant term. This is standard form. This is the most typical form you'll see these in. Yesterday we looked at vertex form and intercept form, so here is standard form. In order to find the vertex in standard form, so to find the vertex in standard form, the x value is going to be found at negative b divided by 2a. The y value, once you get that x value, you're going to plug it into your equation, so the y value is f of negative b over 2a. So again, this is going to tell you your x value. To get your y, you're going to plug in x. On that same note, your axis of symmetry, we know always goes through the x value of your vertex. Your axis of symmetry is going to be x equals negative b over 2a. You can say negative b, or you can say the opposite of b, because it's going to change the sign of whatever your b is in your function. So if we look at the equation, if we do an example, so if we look at the equation y equals 2x squared minus 8x plus 4. So if we look at this equation, we want to find the vertex and we want to find the axis of symmetry. So to find the vertex, we're going to do negative b over 2a. So the x value will equal that. We need to decide what a, b, and c are in order for us to do this. So a is always in front of my x squared term. So right here I have a 2 in front of my x squared term, so a is going to be 2. B is with my x term. So here we have minus 8, which will be negative 8 as my b value. And then the 1 by itself is your c, so that will be positive 4 in this situation. So if we plug that in, the opposite of b. So since my b is negative 8, the opposite of b will be positive 8 over 2 times my a value, which happens to be 2. So this will be 8 over 4, which is 2. So we know the x value of my vertex. So if we're trying to find our vertex, the x value of my vertex will be 2. And we're going to have to plug that in order to find my y value. So if we go back to the equation, we're going to go to y equals. So I'm going back up here to my original equation. And now we're going to plug in that x value of 2. So we've got 2 times 2 squared, because x is 2, minus 8 times 2, again, because x is 2, plus 4. Order of operations tells us to square first, so we'll have 2 times 2 squared, which is 4, minus 8 times 2, which is 16, plus 4. 2 times 4 is 8, so we'll have 8 minus 16, which will be negative 8, plus 4, which will be negative 4. So my y value will be negative 4. The axis of symmetry, it always passes through the x value of the vertex, so my axis of symmetry will be x equals 2. So there's your vertex and axis of symmetry. So your vertex, you do negative b over 2a to get the x value, plug that into your equation to get the y value, and your axis of symmetry goes through that x value of your vertex. Oops. The next thing we're going to do is when we need to convert to standard form. So this will be converting. If I give you the equation y equals 2x minus 3 times x plus 4, and we want to put this in standard form, that means we need to have our x squared plus bx plus c, or ax squared plus bx plus c. This is intercept form, so we need to multiply this out to put it into standard form. We want to do these parentheses first. We want to multiply those out first, so that way it just works out nicer for us. We're going to multiply the parentheses out first, so we'll leave that 2 out front. Don't forget about the 2. When we multiply these, this is where you've probably either used the box method or you distribute twice. I call it double distribute. Some people call it FOIL. However it works, you're just going to be distributing each piece everywhere. So I'm going to start with this first x. So we're going to do x times x, which will be x squared. And then we do x times 4, which will be plus 4x. So now my x has been distributed everywhere. So now we'll come in and we're going to distribute the negative 3. So negative 3 times x is minus 3x. Negative 3 times 4 is negative 12. So that's been distributed now. Now we've got this First, we need to look at these like terms. We've got 4x minus 3x inside. If we combine those first, that's going to make our lives much easier. So we'll have 2 times x squared. 4x minus 3x is 1x, so plus x minus 12. And then, now we need to distribute this 2. So we'll have this 2 distributes everywhere. So we have 2x squared plus 2x minus 24. That's our y equals. Now we have our ax squared plus bx plus c, and we are in standard form. The other way you'll see this is if I give it to you in vertex form. So if I give you the equation y equals negative x minus 2 squared plus 3. The first thing we need to do is understand that x minus 2 squared really just means x minus 2 times x minus 2. So I'm going to rewrite this as y equals negative x minus 2 times x minus 2 plus 3. One of the biggest mistakes I see is people trying to distribute this squared, saying x squared minus 2 squared, which would be positive 4. That is not how it distributes, so please don't do that. You want to make sure that you rewrite it out, and we're going to distribute from there. So again, we're going to leave that negative out front. I'm going to start with my parentheses, but don't forget about the negative out front, and don't forget about the plus 3 there at the end. So when we distribute in here, we're going to have x times x, which will be x squared, x times negative 2, which is minus 2x. Then we come inside. Now we have negative 2 times x, which is negative 2x. Negative 2 times negative 2, which is positive 4. Close my parentheses because that was the end of my double distributing, but we still have this plus 3 out at the end. So now we need to combine like terms in the middle. So we've got y equals, still the negative out front. We're still dealing within my parentheses because we haven't distributed that negative yet. X squared minus 2x would be minus 4x plus 4. And then outside the parentheses is plus 3. Order of operations is multiplying first, so we need to distribute this negative. So we have y equals negative x squared plus 4x, because negative times negative 4x is positive 4x, minus 4. Now since we already distributed, my parentheses go away, but that negative stops distributing at the 4, so we still just have that plus 3 at the end. It does not get distributed to because it's not inside the parentheses. Now you notice we have like terms again. We have constants at the end. So we've got y equals negative x squared plus 4x. Negative 4 plus 3 would be negative 1, so minus 1. And that would be my standard form. The last thing we're going to look at is the maximum and minimum values. If you think about your parabola, we have a max or a min depending on the way my parabola is oriented. If a is greater than 1, or if a is positive, your x squared is positive, then your parabola opens up as usual. As you would think, here's your vertex down here. That max or min is always going to occur at your vertex. So here my vertex is at the bottom. So since it's at the bottom, this would be a minimum. When a is less than 0, I wrote a 1 over there. When a is less than 0, or when a is negative, when you have a negative x squared, then your graph is reflected, so it opens down, which means your vertex is up at the top. This would be your maximum. The maximum or minimum value is the y value of that vertex point, but we're going to phrase it a little bit differently, or we're going to phrase it such that you get to use both of those x and y values. So if I give you the equation y equals 2x times x plus 4, we need to decide what form this is in so that way we can find the vertex. If you think about standard form, ax squared plus bx plus c, that has the x squared already in there. We don't have an x squared written precisely here. Vertex form is your ax minus h squared, so you have in your parentheses the x minus h and the squared outside your parentheses. We don't have that here. Intercept form is where we have two sets of parentheses. This is the closest to that intercept form because this actually is an intercept form. If you think about it, here in this first spot, this is where your R2 is. We want to know where that's equal to 0. So x plus 4 is equal to 0 when x is negative 4. When 2x is equal to 0, if you think about what would x be to make 2x 0, that would be 0. If you can think about it as 2x equals 0, sorry, you can't read that. If you divide by 2, 0 divided by 2 is still just 0. So my first root is 0 and my second root is negative 4. If you remember how to do this, which you need to remember, to find the vertex point, we're going to do r1 plus r2 divided by 2. It's the average of those values, and then you plug it in to find your y value. F of r1 plus r2 over 2. So if we actually go ahead and do that, we've got f of r1 plus r2, so my x value is going to be 0 plus negative 4 divided by 2, which would be negative 4 over 2, which is negative 2. So the x value is negative 2. The y value, we're going to need to plug that negative 2 in. So we've got 2 times negative 2 times negative 2 plus 4, which would be, I'm going to leave this as 2 times negative 2, because those have nothing to simplify. Negative 2 plus 4 is positive 2. So 2 times negative 2 is negative 4, times 2 would be negative 8. So my x value is negative 2, my y value is negative 8. We need to decide if this is a max or a min. So we know we have the point negative 2, negative 8 down here. We need to look at my original equation to decide if this is positive or negative, if my graph is opening up or opening down, so we know if it's a max or min. Since both of my x values here are positive, we've got a positive 2x and a positive x. When I multiply those to put in standard form, if you will, that would give me a 2x squared, which is positive, which means our graph is going to be a standard looking parabola. We do not have a negative x squared, which means this is a minimum point. So the way I want you to write your answer is we have this point, negative 2, negative 8. So we're going to write our answer by saying, I'm going to flip to a new screen here. We're going to saying, so negative 2, negative 8 is our point. And we said this is a minimum. Oops, minimum. So we're going to say the minimum value is negative 8, because the minimum value, the lowest point y value on that graph is negative 8, and occurs when x equals negative 2. So the minimum value is negative 8. The actual minimum is negative 8. It occurs when x is negative 2, because we have the point negative 2, negative 8. So each time you do these, I want you to end it with this statement that says the minimum value or the maximum value, depending, is whatever the y value is and occurs when x equals and whatever that x value is.